video, we are going to be looking at integration by parts. So there is a formula that is used in integration by parts, and that is the formula which says u dv equals to uv minus v du. Another thing that is to be noted is that there is something that is known as Lipet. Some people call it Liate. So we'll look at how this Lipet and Liate work. So I will write it going downwards. So Lipet here. The reason why I wanted to do is that L represents something. It represents a logarithm function. And then I represent inverse trig. So it's not just any inverse, it's an inverse trigonometry. Then P represent polynomial. Then E represent an exponential function. Then T represent a normal trigonometry. And then some people, so before we explain that, we'll see that this is 1, 2, 3, 4, 5. So some people call this Liate. Simple. L is still logarithmic, and then I is still inverse. A, it's actually algebra, which is the same as polynomial. And then T, it's trigonometry. So now we see that when we are using Liate, trigonometric function comes first while exponential comes last. So it means that when we are working with exponential and trigonometric function, it will be your choice to choose which one will you let to be you. Because the reason why we're having this, we're saying that the one that comes first according to this order, you must let it to be u and find the u prime, or we find the du. So we will see how actually that works. So let's look at first problem. Then we have x squared times e to the power 2x dx. According to this, x squared comes first because x squared is a polynomial. So we will let x squared to be our u. Then it's equal to x squared. Then when we differentiate x squared, we get that it's actually 2x. And then so it's not just 2x. Let's say we call it 2x dx because it's going to be du over dx. So it's actually, when you take dx to the other side, it will be 2x dx. Then we have dv here, which is e to the power 2x. Then when you integrate, this time around, the v, you integrate it. When you integrate this, it gives e to the power 2x over 2. So what are we noticing? That is now what we need to do is that we all have everything that is in that formula. What we do is we take our original integral as it was, rewrite here. Then in the place of u, we substitute it was x squared. Then in the place of v, we substitute what we found to be v. Then we say that we have now an integral. So in the place of v, we substitute what is v. And then in the place of du, we substitute du, which is 2x dx. So we can see that 2 and a 2, they cancel out in that step there. So we can rewrite our integral as x squared e to the power 2x over 2 minus now x e to the power 2x over, there is no over 2 now because the 2's they have cancelled. So now we see that now we have that. But still again here, we still have integration by parts. So this time around, again, we repeat the same pattern. We do not have x squared anymore. Now we only have x. So we say that now u is equal to x, then du it's actually going to be 1 dx, because when you differentiate x, you just get 1. Then dv, it's still e to the power 2x. Then when you integrate v, you get, when you integrate v, you get that it's actually e to the power 2x over 2. Then now what we need to do is now we need to go and substitute into the formula. So this was the original integral that was given. So we must not forget what we had here when we go and substitute. So we still have that x squared times e to the power 2x over 2 minus, now we go and work the integral of x e to the power 2x, and we have already separated everything and worked out everything. So now what we need to do is to substitute. So we still have uv. So now our u is x, and then v is e to the power 2x over 2. Then now we are going to have, when we put inside the integral, we have v du. So v is actually e to the power 2x over 2. Then du, it's actually just going to be dx. Then we close that bracket. Then from here, we can simplify by expanding by negative there to distribute that negative inside the brackets. Then we'll have minus x e to the power 2x over 2. This now changes to a plus. We can factor out negative 1 over 2. Then e to the power 2x dx. So maybe we can work on the same page because we are almost done. So let's try to erase some of the stuff that we are having here. Which one is quicker? Let's say eraser. Let's try the eraser. So now we need to integrate this here, right there. So we said that it's equal to, our original integral is e to x to the power 2, e to the power 2x dx. Then we'll have this now, which is x to the power 2, e to the power 2x over 2 minus x e to the power 2x over 2. Then this we need to integrate now. 1 over 2, it's a constant. Then when we integrate e to the power 2x, we get that it's actually going to be e to the power 2x again over 2, then plus c. To show that we have integrated, we write a constant of integration, which is that plus c. This can be simplified to give the following here. We can see that now we have 1 over 2. And then when we multiply by 1 over 2 inside that bracket, we'll have 1 over 4. So now we do not have brackets anymore. So we can take e to the power 2x as a common factor. Then by doing that, the first term will become 2x squared. Then the second term will become 2x. And the last term will just become 1. Then we have plus c. So that's it. We have successfully performed integration by parts. So let's look at another example that involves integration by parts. So now we are working with y variables. I think I have said in one of the videos that do not get used to one variable when we are working in the calculus, because we are used to x. Now it is given in terms of y. So we are having an integral of arctan y. So here it's just to notice that you do not make a mistake. That note that if y is equal to arctan x, for example, then when we differentiate this, it gives 1 plus x squared. But when you integrate it, it will not give you that. It's going to be a different thing. So we do not know what it gives you when you integrate it, and we find out by performing integration by parts. So now if we look at according to Lipet, I'll use Lipet in this video. So log, L is for log, and then I is for inverse trigonometry, then P comes after. So in this case, we can assume that there we have 1, maybe for example, then inverse comes second. So we can let our U to be this inverse tan y. Then when we perform the U, it's going to be actually 1 over 1 plus y squared, then dy there. So let's say that this is more like 1 times arctan y. So dv is actually just going to be 1. And when we integrate that with respect to y, it's just going to be y. Because we know that if we have 1 dx, when we integrate 1 dx, it's actually going to be x. So now we're integrating 1 dv, then it gives us y 1y dv. It gives us actually just y when we integrate. So now what we need to do is, because we know that the formula is u dv equals to uv minus v du. What we need to do is to go and substitute. So we have arctan y dy. What is the v? What is the u? Let's start with u. It's arctan y. Then what is v? It's y. So I'm putting brackets so that I do not get things mixed up. Then what is v this time around? It's y. And then what is du? We can just divide by just 1 plus y squared dy, so that it looks like that. Then looking at this right here, We can use the following formula, that if we're having an integral that has the correct derivative at the top, where now it's f of x, but now we're dealing with y, but it's fine, we can just use it as x. Then there's dx, so we have ln f of x plus c. So what happens that we can see that if our f of x, if we say that it's actually similar to 1 plus y square, then f prime, now just bear in mind that we are actually differentiating with respect to y. It's going to be 2y, but here we do not have 2y. We can put it, then divide it at the bottom. Then the final answer now, it can be rewritten to be just y arc tan y, then minus minus 1 over 2 ln of 1 plus y square plus c. So let's look at another problem. We are done solving this problem. So what else can we have again if we are working with integration by parts? So let's look at another problem. Let's go back to red marker, black actually. So if we're having x ln x dx, then we see that it's Lipet. Logarithm comes first before polynomial x. We can consider it to be a polynomial. So logarithmic comes first. It's actually the first in the Lipet rule. So we will let our u to be ln x. Then du is equal to 1 over x. Then we can just write the x there as well. So we know that every time when we differentiate ln x, it becomes 1 over x. That one is a simple one. Then when we have dv, it's actually going to be what? Now x. When we integrate x, we say that it's going to be v. Then x gives x to the power 2 over 2 when we integrate it. So what we need to do is to remind ourselves maybe once again of the formula, which is actually u dv is equals to uv minus v du. Then we have x ln x dx is equals to, the u is ln x, and then v is x square over 2 minus v again is x square over 2, du is 1 over x dx. What we need to do is to simplify. Perhaps now we can start with x squared over 2, then ln x. It looks better in that way. So we can see on inside the integral, we have x squared over x, and we can still factor out 1 over 2. Then x squared over x is just going to be x dx. Then if we continue to solve here, we now will have x squared over 2 ln x minus 1 over 2. When we integrate x, we know that it's going to give us x to the power 2 over 2 plus c. And this problem is done here. We can just simplify here to have 1 over 4 x squared plus c. Or if we want, we can still factor out x to the power 2 over 4 Then we'll have 2 ln x minus 1 plus c. Then let's look at another integral which is in a different format now. Let's look at the relationship between exponential and trigonometry. So e to the power 2x cos 3x dx. So I said that when we're having an exponential, it's up to you which one we can you take to be. It's up to you which one you can take to be or u. Then if we say that the u is equal to e to the power 2x, then du it's going to be 2e to the power 2x. Then if we say that dv now is cos 3x, there's someone making noise outside. Apologies for that. Let's continue. Then v is equal to, when we integrate cos 3x, we get that is actually going to be sine 3x over 3. So that's what we get. And then for reminder, we can write our formula there, uv minus v du. It's better if we write our formula there so that we do not get things mixed up. Then we will have e to the power 2x cos 3x dx. Then we said that our u is e to the power 2x. Then the v is what? It's sine 3x over 3. Then we go and subtract there. We said it's v du. V is sine 3x over 3. Then du is times 2 times e to the power 2x dx. So we can write dx there. Some people, they don't write it, but we can write it so that we don't forget to write it here again. We can simplify now what we are having. Sine 3x, then if we can factor out 2 over 3 outside of that integral, we'll be left with sine 3x e to the power 2x dx. So we realize that now we still have integration by parts, and I can see that when I integrate sine, it goes back to cos. When I differentiate exponential, it remains that exponential. So what can we do? We take it again. Now we say that our u now it's still e to the power 2x. When we differentiate, it's going to be 2e to the power 2x. So we repeat what we did. Then dv now, it's no longer a cos, it's a sine. So it's sine 3x. Then v, when we integrate sine 3x, we get negative cos 3x over 3. And remember, now we are integrating, we are not differentiating. So what we need to do from here is to take again our original integral, which was cos e to the power 2x cos 3x dx, and rewrite the entire solution. So it was e to the power 2x sine 3x, then minus 2 over 3. Now I need to evaluate this integral using by parts, which is saying it's uv. So u is e to the power 2x. V, what is v? V is negative cos 3x over 3. Then integral of v du. So v is negative. So I can see that I can change this to be positive. So it's going to be positive cos 3x over 3. So it's v du. Du is 2 e to the power 2x. Then dx there. Then we can close the bracket. Then again, we can try to simplify what is inside the bracket again. So we have e to the power 2x sine 3x. Then when we simplify the first term, it will give us a plus. Now it's going to be 2 over 9 e to the power 2x cos 3x. And then when we simplify that side where there's integral, we have 2 over 3. When we multiply by 2 over 3 outside, we'll get that it's negative 4 over 9 integral of e to the power 2x cos 3x. So what we realize now is that this integral has returned to its original form. We have e to the power 2x cos 3x. So it means that it will keep on alternating. So we can do it up until infinity if we don't stop. So we can stop there to integrate. What can we do now? What we need to do to find the solution is to take it to the other side. So we can see that on this side we have e to the power 2x cos 3x. Then when we take negative 4 over 9 integral of e to the power 2x cos 3x is going to be positive 4 over 9 e to the power with the integral. Then here there's still dx, e to the power 2x cos 3x dx. Then now we can write this. We leave this on the right hand side. So it's going to be e to the power 2x sine 3x plus 2 over 9 e to the power 2x cos 3x. So when we are here, we are almost done. What we need to do is to make our integral subject of the formula. So let's write on another page, perhaps. So here we can factor out e to the power 2x cos 3x. And when we do that, we say we factor out e to the power 2x cos 3x. So on the first term, we have 1. So it's going to be plus 1. On the second term, we have 4 over 9. So it's going to be 4 over 9. Then dx can still be there. And as a matter of fact, it has to be always there. Then on the other side, we can factor out. What can we factor out on the other side? And then let's check something before we proceed. This term here, it's actually divided by 3. Even here, it's divided by 3. Even here, it's divided by 3. Even here, it's divided by 3. So on the right hand side, we can take out 2 over 9 as a common factor. because 2 over 9, it's smaller than, is it smaller? Yeah, I think it has to be smaller than 1 over 3. I'm not sure. I'm not good at adding maths like that. So if we take out, let's take out 1 over 9 instead of taking 2 over 9. Let's take out 1 over 9. When we have take out 1 over 9, and also with the e to the power 2x, e to the power 2x. So we'll be left with this side, will be left with 3 sine 3x. Then there we will be left with plus 2 cos 3x. If we take it out like that. So it's up to you how to you factorize it there. And then when you are factorizing, you must have a goal that you are trying to achieve. So e to the power 2x cos 3x. So here I can cross multiply, and then I will, when I cross multiply, 9 times 1 is 9, then 1 times 4 is 4. 4 plus 9 is 13 over 9. Then we have it like that. Then we have 1 over 9 e to the power 2x, 3 sine 3x plus 2 cos 3x. So when we are here, we can divide here by 13 over 9. And then dividing by 13 over 9 is the same as multiplying by 9 over 13. So we can see that this term here, it will be gone. Then this side will cancel a 9 and a 9. So our final answer works to cos 3x dx is actually equal to 1 over 9 e to the power 2x, 3 sine 3x plus 2 cos 3x. Then on the last step, we can write plus c to say that we are done. We can integrate it up to that point only. So let's look at the last example, and then it's going to be example number 5. Then we have x arctan x dx. So we have to follow Lippert all the time. Which comes first? We can see inverse comes first before polynomial. So we have to differentiate arctan x. So u is equal to arctan x. Then differentiating arctan x, we know that it's actually going to be 1 plus x squared. Then we can write the x here as well. Then what happens now? It means if we choose arctan x as u, then the v is actually to be x. Then v, when we differentiate, when we integrate rather, x, it becomes x to the power 2 over 2. Then again, let's remind ourselves the formula. So it's u, v, and then v du. So these formulas, when you work with them, you won't forget them, but it's always advisable that you write it there so that when you are substituting, you don't substitute wrongly. So we will have our original integral as it was given in the question is arctan x. Then it's equal to my u, it's arctan x. Then v, it's x squared over 2. then over the integral of v is x squared over 2 times du, it's 1 over 1 plus x squared du dx. So what is needed now is to do some simplification. So we see that we have x squared over 2 arctan x minus, we can take out 1 over 2 outside of the integral, then we have minus 1 over 2, then we have x squared 1 plus x squared. So what do we notice now is that we're having x to the power 2 on the numerator. It's in an equal degree with the denominator. So we need to apply long division in that case so that we can be able to integrate. It's going to be difficult for us to integrate something like that. So we can extract this term here so that we can integrate it using, let's apply long division for now, then we will see where it leads us, because we do not know at the moment. So we take the denominator outside this division operation, then we put the numerator inside. We take this, so it's actually advisable that let's write this, because let's write it like this, x squared plus 1. So when we take x squared divide by x squared, we get 1, then we subtract here. 1 times x squared is x squared, 1 times 1 is plus 1. So this one and this one, they cancel, then we are left with negative 1. So what we do, we take this one here, then we write it here, then we take this one, so we say minus 1 divide by this one here. So it's going to be like this. So now this is the division form. It's the same, this and that, and this is what is here is the same. So we can go and replace what is there. So 1 x squared over 2, then over 2 here. So here we will have integral of 1 minus 1 x squared plus 1 then dx. Then we can distribute the brackets there, but when we are here, we are almost done. Let's just write it in a nice form. So we can have, when we multiply inside there, we can have 1 over 2 integral of 1 dx. It's just going to be dx. Then plus, because here we have a negative, so it's going to be 1 over 2 integral of dx over x squared plus. Then we can see that this is arctan. It's an integral of arctan x. It leads to arctan, and our a is 1, so it's just going to be arctan x. Then we have x squared over 2 arctan x here. Then we have 1 over 2 as a constant. When we integrate 1, we get x. Then we have 1 over 2 here. When we integrate there, we say that it is arctan x. Then from here, it is good enough to leave it here, but we can see that arctan x is a constant, so we can have arctan x maybe 1 over 2 arctan x. But I think it's not necessary to do this here. Then we'll have x squared plus 1, then minus 1 over 2x in that way. So that's it. I think from today we will end here with integration by parts. Look out for more videos. Please subscribe so that we can stay tuned. Until next time, thank you.